Welcome to qnawire.
Okay, we have a theoretical Newman projection that we need to convert to its wedge-dash. So there's two ways that we can have a Newman projection, and since these pictures never uploaded, there's no way of knowing what you've got, so I'll just do it for both ways. Right. So first would be a staggered conformation, and I don't know what groups you have, so I will do A, B, C, X, Y, Z. Okay, so the way I look at this is I notice the relationship between A and Z, and I know that there's a bond between this front carbon and the back carbon. So from left to right, I'll do a bond from the front carbon to the back carbon, and then I'll draw A and Z such that they are anti to each other. So I'll draw A up and to the left, and then Z down and to the right. And then I'll add the others, right? So if I'm looking at that atom, C should be on my left and B should be on my right, right? So C will be a dash in the back and B will be a wedge to the front. I also know that I'm going to, if looking at it from, well, I don't really have to think about looking at it from the other side. I just know that C and Y are going to be on opposite sides of the molecule. So if I have a dash to C, I must have a wedge to Y. And similarly, if I have a wedge to B, I must have a dash to X, right? Because they're on opposite sides of the molecule. They're anti to each other, just like A and C were. Okay, now the other option is that we look at, this was staggered. The other option is that we look at eclipsing, right? So that's when we have in the front, we have A, B, C, but then X, Y, and Z are not in the empty spots on the side, but like, overlapping essentially. Okay, so I'll still go from left to right. I'll go the front molecule with A, B, and C attached, and the back carbon with X, Y, Z attached. But now I'll go up and to the left with A, and up and to the right with X, right, to represent the fact that they're basically overlapping each other. Okay. So when I now consider looking at the front side from here, once again, C should be to my left or in the back, so I'll draw dashes to C and a wedge to B. Okay, and now C and Z need to have the same sort of bond to it, right? Because both C and Z are in the back this time. So, C and Z are, if C is a dash, then so should be C. And if B is a wedge, then so should be Y. Okay, so that's the two different types of Newman projections that you can have and how you would go about converting them to a bond line with wedge and dash drawing.